So my company, Collins Aerospace, has a long-standing history with involvement in the FACE Consortium. We've been involved with the consortium since its inception in 2010, and we've been a sponsor member from the very beginning as well. And we've held a number of leadership positions in both the business and technical side of the consortium since that time. So I think it's fair to say Collins, along with a number of other member corporations, have done a lot of the heavy lifting and made significant contributions to the standard. You know, we're also one of those corporations, you know, walking the walk, so to speak, implementing software using the FACE standard. You know, a good example of this is a certificate we received for the first FACE conformant application back in 2016 for the MFMS 1000. You know, and since then we've continued to add FACE apps to the shelf. I was looking the other day, and I think if you look, Raytheon Technologies, which is my parent corporation, has nearly half of the FACE conformance applications on the shelf. So overall, Collins Aerospace has been highly involved in the consortium and the development of the FACE standard, and really would be considered a champion of FACE. You know, and from a significance perspective, you know, I think FACE is very significant and is going to be the open standard the defense market leans on for the future platform developments. You know, you're already kind of seeing this with platforms like Future Vertical Lift. You know, FACE has the advantage that it has a conformance test suite. You know, companies developing applications using FACE standard can't just say they're conformant, but they really have to prove it. And that's very powerful when you talk about the future of open systems architectures. You know, I really could see a future where providing real proof of portability becomes table stakes if you want to win platform positions. So, you know, I really do think FACE is going to have a significant impact in the future military avionics market space.
Great, excellent. Thank you, Levi. And indeed, you brought up Future Vertical Lift, where FACE has become obviously the standard that all Future Vertical Lift solutions will have to follow across the board. And that includes, of course, also the modular open system architecture, MOSA elements of that. So thank you for bringing that up. Steve, if I could go maybe to you with the same question again about your company's involvement in the consortium, and then from your perspective, the significance of FACE as a standard.
Yeah, certainly. So Rapita Systems is actually relatively new to the FACE consortium. I personally have been involved for a number of years and encouraged my company, my new company, Rapita, to get involved. Rapita does software verification tools and services, especially for aerospace, focusing on safety assurance and on performance. So the FACE consortium is a place where government and industry collaborates exactly in that area, providing open architecture avionics. So it's a natural fit for us. Our particular involvement, we're a small company, so we don't have as many people in many areas of FACE, but I am currently chairing the EA25 Airworthiness Committee, so that's where our primary involvement is. In terms of significance, I think everything Levi said made good sense. I wanted to point out that there's been previous attempts to provide standards for open architecture that have never quite gained the legs that FACE has. I think FACE is unique in that it now has 10 years of staying power. So I think compared to many of those other efforts, FACE is the one that seems to actually be gaining ground, showing up in solicitations, showing up in real products. Levi mentioned one of the drivers of that was the conformance testing that ensures that you actually are meeting the standard. I think another unique thing about FACE is that not only did they produce a technical standard, but there's a business aspect. So trying to put all the pieces together to support the standard, I think, is part of what's made it successful.
Indeed, and thank you for pointing out the 10-year legacy. That's a significance, obviously, in terms of standards. And I think it speaks also to the broad adaptation of the standard across the industry. So a good point. And I'm sure we'll come back to the EA25 airworthiness later on in our conversation, but that's another good point. And in terms of opening remarks, to wrap this up, Alex, over to you again. Same question. How does Wind River looks at FACE in terms of your company's involvement and the significance for the industry? And Alex, I think you're on mute.
Indeed, I am getting used to these platforms. Is fun. Thank you, Roberto. Wind River has participated in the FACE business and technical working groups for over 7 years now. And we've put few of our products through the FACE conformance test that Steve mentioned in their previous remarks. We are seeing FACE becoming more and more relevant to the US Air Force, Army, and Navy. And in fact, Wind River has always been very customer focused in our approach to business, with the goal of helping our customers reduce costs across the life cycle of their product development. And one of the key drivers here is around open architectures and open standards, which allow for portability and reuse of software components. Looking at commercial avionics, Wind River worked very much with our customers to evolve the ARINC 653 standard and supply solutions for solving the complexity of integrated modular avionics with our VxWorks 653 solution. This allowed our customers to develop modular applications that can be fully tested and integrated into the system, which supports multiple applications at different safety levels. In fact, Wind River solutions have always followed an open standard strategy. And what is interesting about the FACE standard is how they build upon existing open standards rather than reinventing the wheel. As such, FACE built upon standards such as ARINC 653, ARINC 661, and POSIX to create an open architecture approach to military avionics. Wind River FACE solutions expand upon the tenets of open architecture, integrated modular avionics, and modular open systems architecture, as you mentioned, Roberto. And this enables our customers to create innovative, reusable modular applications that can be deployed in advanced military systems. And I think Steve already said this, but one consideration I think about FACE that's unique is the approach of building a business guide that allows, as an open architecture approach, the FACE standard to look to solve issues around conformance, contracting systems based around FACE, and other business drivers, which is very different to other open architectures. Wind River will continue to promote FACE with both investment as well as leadership into future systems. So back to you, Roberto.
Great, excellent. And I'm sure, again, in the conversation, we'll come back to the business guide and the business drivers. I think those are very important. But maybe before we get to the business elements of the doing business with FACE, through FACE, in conformance with FACE, maybe let's talk a bit about specifically the safety critical applications. Let me go back to Levi for this question. So Levi, as you think about FACE, are there any specific design elements of FACE that you think make it a particularly good choice when it comes to developing safety critical applications?
Yeah, so, it's kind of a misconception that FACE was not designed for safety critical applications. As one of the co-chairs of the technical working group, I frequently hear FACE was designed for non-flight critical applications in the back of the aircraft. It's one of those tropes that you're going to hear frequently if you attend the face-to-face meetings. But it's interesting when you look at the makeup of the FACE technical working group leadership team. You're going to see a lot of representations from OEMs and suppliers that do safety critical on a daily basis. In fact, many of us kind of have to pull ourselves back from time to time to consider things outside of safety critical. So that's why when you look at the FACE standard itself, you see that it was kind of built on a foundation of safety. Here's kind of a few examples. FACE has a safety critical operating system profile. It was defined by the experts. One of our hosts here, Wind River being one of them. Also, FACE has the conformance element of it. So as you're developing applications, you know when you're done that you're going to have an application that's going to be certifiable. It's going to be portable when you get done as well. And then finally, it's built on top of open standards, kind of like Alex had said. It's built on top of ARINC 661. It's built on top of OpenGLSC. So it truly does have a number of design elements that have been specifically injected to support safety critical applications. So really, as companies are developing their applications, they kind of have to ask themselves, why are they not choosing to use FACE as the base of their development platform? Thanks, Roberto.
I think that's a very good question, actually, Levi. Why not face, given again how widespread the standard has become? Now, safety critical applications are a big deal, obviously, to everybody on this panel, but I know specifically to Wind River Systems. So, Alex, anything else you'd like to build on this?
No, and I think Levi already mentioned this, and I mentioned it in my introduction, but you know, FACE builds upon existing standards. It doesn't reinvent the wheel. And the standards that it builds upon are standards used in commercial avionics for safety critical systems. So ARINC 653, ARINC 661, and the components that they choose or they've chosen to reference in the standard all have good solutions when it comes to developing safety critical applications. Actually, a good example of this is outlined in a joint white paper between Collins and Wind River that shows the development of a multi-core based flight display system supporting FACE and ARINC 653. And that can be found on the Wind River and Collins website. I think we're providing a link at the end of the panel session.
Excellent, very good. Well, thank you both for addressing that subject. And now, Steve, I'd like to go back to actually one of the items you brought up in your opening remarks, and that was the EA 25 Airworthiness Committee. So if the FACE standard does not directly address flight certification, then what is the role of this FACE EA 25 Airworthiness Committee? Could you share maybe with the participants a bit of that background? Because a lot of folks may not be familiar with that.
Yeah, absolutely. It's a new committee within FACE. So first of all, just building on what Levi and Alice have just pointed out, the products developed under the FACE standard do fit well under safety critical applications as well. But the standard itself does not address assurance of airworthiness. It's not about flight certification. It's about standardization of interfaces of APIs to provide portability, interoperability, but it doesn't address flight certification directly. Since FACE was started, one of the technical working groups has been on safety, and their particular mandate was to ensure that each edition of the FACE technical standard did not impede flight certification. So there's a group specifically tasked with making sure that the FACE standard didn't get in the way of flight certification. So you could think of their goal as do no harm. The EA25 group is a little bit different. In the last year or so, some of the folks on leadership for FACE have suggested that because there's some work that goes into showing conformance to the FACE standard, couldn't that somehow be used towards flight certification? That is, can we go beyond that do no harm mandate to actually say, is there some duplication? And that's what the mandate of the EA25 subcommittee is, to look for which activities and artifacts are produced as part of FACE conformance that can then be used in the subsequent effort of flight certification. So that committee is just getting started in this last year. In fact, if there are folks on the call today who are FACE members and are interested in this subject, I'd welcome you to join our group. Look for EA25 and the FACE areas on the website, and certainly we welcome you to join us. Let me give you a little bit idea of where we are with the committee. We've identified a number of airworthiness standards and guidance that may be applicable. As you may know, each military branch has its own airworthiness authority. So there's a variety of areas you might look for this. And then just recently, we decided to focus on two primary documents, MIL Handbook 516C, which is the airworthiness certification criteria. And we're also looking at DO 178C. Now that is a civilian standard. However, many of the military airworthiness authorities will accept DO 178 or reference it. So we've chosen those two as our examples to now look at what activities under FACE contribute to the evidence that show airworthiness under those two standards. So stay tuned, that work is starting, and I think should produce some good fruit to provide that benefit of showing effort under FACE can help you when you go to flight cert.
Excellent. Well, thank you for sharing that information, and thank you for extending the offer to today's participants to contribute to the efforts of the EA25 Airworthiness Committee.
I imagine we have some experts. In fact, I just was glancing at the participants. I see a few folks on there I would love to have participating on the committee. So you know who you are.
Wonderful. From my perspective, listening to you describe this committee, I think also speaks to the fact that FACE as a community at large is continuously evolving.
Okay.
It's not something that is set in stone and it's going to stay and stagnate. It is a continuously evolving community of interest because nowadays that's what standards have to do as well, just as technologies do.
That's right. You'd think that after 10 years, all things would be done, but there are quarterly F to F meetings that are quite active in a number of areas. Yeah, it is absolutely a very living and active collaborative group. Yeah.
Excellent. Thank you for that, Steve. Let's see, earlier we brought up Future Vertical Lift. There's been a number of different US programs that obviously are working with FACE. But let me ask you a question that sometimes I think different folks also here in the community, and let me go to Alex Wilson for this one. Since membership in the FACE consortium, Alex, as I understand it, is limited to US persons and US entities, why is it so relevant then for the rest of the aerospace and defense market outside of North America?
Yeah, good question, Roberto. Yeah, it's true. Participation in the development of the standard itself is restricted to US entities. And so being able to work and join the working groups that Steve just requested is restricted in that way, unfortunately. And in fact, the ability to see draft versions of the standards as well as they're being developed is restricted. However, all the standards are published on the Open Group website and can be downloaded free of charge. So once the standards are released by the FACE consortium, they're freely available for people to use on projects if they'd like to. And it's worth remembering, we've mentioned this a couple of times, that FACE does build on existing standards such as ARINC 653. And these are all open standards as well. So if you're really concerned about or have strong feelings about how ARINC 653 is constructed or the APIs in POSIX, then of course you can join those standards and participate in the development and guidance of those standards. Now, many of our customers have US operations anyway that would allow them to participate in the standard. And indeed, many of our international customers also sell into the US and so would need to do that and make use of the FACE standards in order to bid on US projects like Future Vertical Lift that you mentioned earlier. And this also applies to a certain extent to systems exported by the US. In this case, it's more of a business argument for suppliers to use FACE for, just for internal use, but also for export use, because otherwise you'd have to duplicate everything that you're developing. Although you may have functional changes that you restrict certain products to, but the basic architecture, the way you construct your system could be based around FACE. And in some cases, it might even make sense for international partners to also adopt FACE for systems built locally, because these systems may have to integrate into US-based airframes, for example, and then FACE conformance would be kind of interesting to keep. And added to that, I think someone mentioned earlier about the face-to-face meetings. These are generally open exchanges with participation from international audience. And so you can go to the face-to-face meetings and learn about FACE systems and see demonstrations and hear about best practices. So in that context, you can learn a lot about FACE and make use of them.
Excellent. So yeah, certainly something that is driven from a North American perspective, but definitely rooted in global international standards and certainly with international and global applicability. So yes, that's the way I look at it. And speaking of global operations, obviously Collins Aerospace has operations all around the world and customers from all around the world. Levi, you probably have a perspective on this in terms of how FACE as a standard is being used beyond US borders.
Yeah, it's interesting. The companies, I've talked to internationally, have really expressed an interest in starting to adopt, standards, open architectures, and FACE is certainly one of those ones that they're considering. Now I do hear from time to time, they express concern about not being able to actively participate, but on the other hand, they really do see the value of the things that we're bringing, we're completing at the FACE consortium level. Items like the conformance test suite. I'm going to keep hammering on this because I really think the conformance test suite is one of those viable items that we're creating as part of the FACE consortium. They see an opportunity to also leverage, the applications that we're developing as part of FACE. You know, eventually we're going to have a full FACE shelf of apps that they're going to want to pull in and utilize in their platforms as well. You know, and finally, you know, I think like Steve said, we have 10 years of development under a belt. You know, and now I understand that a lot of folks can suffer from the not built here mentality, but it's very appealing for the international folks to start to draw on the maturity of what we've done with FACE. You know, so I really would expect to see some adoption of the FACE standard internationally in probably the next few years.
Excellent. Well, I think that's an exciting prospect that we have to look forward to, and I think one that indeed we're gonna see very soon. Let me go back to Steve. Steve, obviously you have significant experience in airworthiness and flight certification aspects of systems. Maybe could you give us maybe an example or two of a challenge, or maybe multiple challenges as you see it, when it comes to flight certification of a FACE conformance system?
Sure. Yeah, I'm going to dive down a little bit into an area that connects with the work I do at Rapita, and this is what actually drew me to start working with them, is the challenge of multi-core processors. First, let me mention the FACE technical standard is agnostic with regards to hardware. It doesn't really dictate which hardware you should use. However, there's three profiles: the safety profile, safety extended, and security profile, that all require the standard that Alex mentioned, the ARINC 653 partitioning standard. If you're doing partitioning, that probably means you're on a reasonably powerful processor in order to support multiple partitions. And that probably means you're looking at something that is reasonably modern, which is probably going to be multi-core. So many FACE software systems are going to end up running on multi-core. It's not necessary, but it's likely. And once you go to multi-core, there's some interesting challenges that arise in regards to certification. The idea of partitioning, ARINC 653, has been around for over 20 years. And assuring partitioning, robust partitioning under, say, DO-297 for a single core, a unicore system, that's largely a solved problem. People have done it many, many times. With multi-core, the problem of assuring that isolation, that the partitioning truly is robust, is much more challenging. You now have to deal with the fact that multiple partitions are running simultaneously, potentially accessing resources within the system, and you have to show that those are isolated. So assuring that, certifying it for safety critical applications is, I'd say, a current challenge that many folks using FACE are going to need to approach. There is guidance for this. It's a CAS 32A currently. It's a position paper from the FAA that indicates that you must show mitigation of multi-core interference channels. And those interference channels arise because multiple cores potentially could be contending for a shared resource, for example, a last level cache or a main memory in the system. And as soon as they start that contention, you potentially have broken the partitioning. So the job of certification is you have to show with evidence that has been mitigated. So this is a problem that's been out there for probably 10 years. People have been thinking about it, but only now are systems starting to appear with mixed criticality, multiple partitions running on multi-core. Collins and Wind River are two that are getting very, very close to that flight certification in such a system. So Rapita has also been working in this area. Our contribution has mainly been in ways to verify, to measure interference between multi-core systems and ensure it's been mitigated. Our approach is to provide tools and services that use what we call Rapidemons is our brand name. It's an interference generator which tests and measures whether a partition can withstand the interference that is produced on another core. So it's an area that is currently a challenge, and I think our panelists here have all experienced that. Rapita is one of those companies providing the tools and services to tackle it. So that's, I know there's a deep dive, but that's one of those current challenges right now, one I'm excited about tackling.
Excellent. Well, no, and it is particularly important, obviously, to aerospace and defense as an industry at large. And I know Wind River obviously has spent significant resources when it comes to the certification of flight as well as mission critical systems. So Alex, I was wondering if maybe you want to comment on that and kind of the Wind River perspective on this challenges of flight certification of a FACE conformance system.
Yeah, I think there are several things that could come up. One interesting thing about FACE is actually getting back to Levi's been plugging the conformance tests. The way we test systems within the FACE environment is we test components against particular segments within the architecture. Steve mentioned the safety-based profile, for example. So we would, for instance, test our operating system against the safety-based profile, and you would get applications tested against the other segments. This guarantees that if you pick different components that are tested against the same standard, the same version of the technical standard, you could relatively easily integrate those together and have them working. But from a safety certification perspective, you would still have to make sure that you follow guidelines for meeting the requirements of something like D0178C. So if we look at the commercial market, for instance, in integrated modular avionics, typically the system would be architected around the ARINC 653 standard so that we could have multiple applications conforming to that standard plugged into the same base module. And then you would follow a standard like RTCA D0297, which specifies the roles and responsibilities for the different suppliers and application developers in terms of what they need to provide for the safety certification. And I think that's key. So you can pick all these components, that guarantees the interoperability in terms of how they'll work in a FACE environment, but you also need to make sure that you pull together the safety arguments for each of those and integrate them into the full system at the end of the development to make sure you have a consistent safety argument to the safety authority.
Yes, and indeed, the generation of all those artifacts that then have to substantiate that certification process, that's a significant effort, but one that is obviously of fundamental importance to airborne systems that we're talking about. Alex, maybe I could continue with you and kind of pull on a related string. We're using the term FACE conformant quite a bit. We're talking about FACE standards and being conformant to a set of standards. So let me ask you a question. If one were to base their system on a FACE conformant operating system, does that automatically mean that it would be FACE conformant?
That's Roberto, that's a very interesting question. So I actually did a little bit of research on this because just to make sure that I have the right phrasing, and I know this is a very sensitive area for how you describe software components or conformance or compliance or all those kind of nice terms that we have used over the years with different open standards. FACE conformance is for software components or units of conformance or units of portability of the system. And if we look in the FACE technical standard, it specifies that a unit of conformance, or UOC, is a software component or domain-specific data model designed to meet the applicable requirements defined in the FACE technical standard. So the provider of that unit of conformance basically can claim to be conformant to the standard once it has completed the FACE verification process and been approved by one of the approved verification authorities and has a valid statement of verification. That's quite key. So for example, Wind River has 3 products which we can claim to be FACE conformant. Our VxWorks 653 version 2.5 on PowerPC architecture has been verified to meet the applicable requirements defined in the FACE technical standard 2.0. In fact, this was one of the first products to go through to be verified against the safety-based profile in the technical standard. Our Helix platform for ARM and Intel architectures has been verified to meet the applicable requirements for the safety-based and security profiles in FACE Technical Standard 3. And recently we put Wind River Linux through, and that has been verified to meet the applicable requirements for the general purpose profile in the FACE Technical Standard 3.0. And for all of these, we have a valid statement of verification, which is available on request or can be viewed in the FACE library. And all of these examples are against the operating system segment, different profiles within that. So the units of conformance for other segments also leads to conformance. So the IO services segment, the transport services segment, the platform specific services segment, these all have, you can all be conformant to those. So currently the complete system isn't tested to be conformant. So systems can specify that they're built out of face conformant components, but you don't, your overall system, you don't use the terminology, my overall system is face conformant. At least maybe the other panelists have an opinion on that, but certainly that's what I read in the guidelines given on the face standard page.
Yeah, no, I think that's an important distinction in terms of conformance, not at the system level, but conformance at the component or subsystem level. I think this is an area, Stephen, where Rapita also has had significant experience. Maybe you can share some of your thoughts.
Yeah, I'll just add a couple of follow-on clarifications. Conformances to a particular edition of the technical standards. You heard Alex calling out which standard they were conformant to. So that's one nuance. Also, there are sort of three steps. Alex mentioned the verification authority. That's the big hurdle. Then there's a certification authority, and then finally getting listed in the library. So you know that a product is face conformant if you find it in the library. So one can go look that up and see those products listed. Raytheon Collins has quite a few of them in there. You can see which edition it's certified against and which segment of the face architecture they're fulfilling. And indeed, it is by unit of conformance. So you don't have a face system, but you do have components which are individually face conformant. And you may have heard the term compliant or aligned. Those are not preferred terms. The one that's meaningful is conformant. And so if you're certified to be conformant to the face standard, that means you are in the library. Anything short of that, a partial credit really doesn't have any meaning. You're either in or you're not. So once having passed that VA, CA, and then the library, now you're considered conformant.
Excellent. Well, thank you for that further clarification and for outlining those three levels, so those three steps necessary before you can get into the library. That's a good point. So let's see, maybe I'll come back to Levi. You know, we kind of started at the top level. I think we've taken a couple of good deep dives in some of the critical aspects of face conformance, but maybe Levi, let me ask you to take us back up again to more of the strategic conversation. So when it comes to face and specifically, what new safety challenges do you think a user may encounter in a digital world where face conformance, from my perspective, appears to be really essential?
Good question, Roberto. So, you know, I would argue that the face standard and conformance to the face standard does not inherently drive any new additional safety concerns to the overall certification process. You know, it's a standard, it brings with a set of requirements that must be implemented, you know, just like any other software standard we work with day to day. You know, conformance is an effort that takes place outside of the certification process, you know, and depending on how you design and test your software, it really should have minimal impact on the overall certification of your product. You know, so, you know, where does that leave us? You know, it's my assertion that in a well-architected system, face actually reduces safety challenges and furthermore creates business opportunities for those who fully embrace it. You know, the conformity element of face, along with the data model, allows system integrators to understand well ahead of time how to integrate any new face component into their platform. You know, companies with experience in designing robust modular systems, you know, are going to be able to take full advantage when it comes to integrating these face units of conformance. You know, they're going to have the tooling in place to auto-generate code from the data models and a platform in place ready to take these applications. You know, really, the most masterful practitioners of face are going to have architectures with modular components built ahead of time. You know, with these modular components, they'll have coupled the certification artifacts, the conformance artifacts, ready and waiting for face UOCs to drop right in. You know, so really, it isn't what new safety challenges will you encounter, but more what new opportunities exist in the digital world where face conformance is essential. You know, conformity brings with it synergy. And when we can all bring our products together seamlessly to create an even better product to supply the defense market space, you know, we're all going to win. You know, this is really why conformance is a necessary element of face and the future success of the standard. So, you know, we as an industry should not be scared of face conformance. We really need to embrace face conformance and see it as the opportunity it truly is.
Thank you for that perspective, Levi. As I listen to you, what I'm really hearing is the fact that really through FACE, we can actually reduce development and integration risk and actually accelerate time to market for new capabilities and new products. So I think that's, from my perspective, that's an exciting value proposition. Steve or Alex, either one of you want to comment on this?
I want to highlight one thing that Levi mentioned just briefly there. He mentioned the data model. The data architecture is an element of the FACE standard that might be somewhat new to folks that have been in the aerospace avionics industry for a while, but it's an important area that I think adds some additional standardization and provides good design up front. And that good design long-term provides some benefit. So I think it may be challenging for folks that haven't had that mental model in place before about thinking about the data architecture. But once you get your arms wrapped around it, it does provide additional standardization and a good way to manage the overall complex design. And I imagine that that's going to be the case as you go to certification as well, as the cert authority may not be familiar with data architecture driven designs like this, but that's going to become more standardized because space is being used more commonly, and that just smooths the communication. So long term, I think that kind of well thought out design is going to benefit everybody from the developer all the way through to the cert authorities.
Excellent, very good points. Alex, I'm just looking at the clock, so if it's okay with you, I'm actually going to jump onto the chat and see if there are a couple of questions that all of you would like, or any one of you would like to address, but then I'll come back to you, make sure that everybody has a chance to offer the closing remarks. Let's see, here's a question that has to do with the FACE and CERT for DO 178C. So the question is, what is your opinion on providing an operating system that is compliant to the FACE-based safety profile instead of CERT for DO 178C, DAL-C, or higher airworthiness certification? So who would like to take a stab at that one?
I'll maybe start, but it feels like Alex probably should jump on this too. But I just want to say, line you up there, Alex. But in a way, I don't think it doesn't sound like an either or question to me. I would say, you could be conformant as a OSS, the operating system segment, conformant to one of the FACE profiles, for example, the safety profile. But if you're going to fly, typically now you're going to then subsequently look for flight cert. So I'd say it's not an either or, and you probably are going to start with that FACE conformance certification. Be sure you have your APIs in place and that's been proven correct under the FACE conformance process before you go for DO-78. So I'd say, yeah, you could do either one, but most likely you're going to do both. And the order probably is starting with FACE to be sure you've got an OSS that is FACE conformant, and then moving on to flight cert at that point.
Yeah, Steve, I think you said it there. They're addressing different areas. The conformance to the FACE base profile, safety base profile. This really gives you this really addresses the modularity and interoperability arguments, the sort of stuff that Levi was talking about, so that we can make sure that different units of conformance plug together and interoperate, providing modularity. The safety standard is then over on top of that. So you would do both. They wouldn't replace each other.
Excellent. Thank you for answering that. I'm back into the Q&A, and this question has to do with the deterministic behaviors, which of course are very important for any real-time operating system. And the question says, how tightly coupled are deterministic behavior and FACE conformance?
That's a good question. The FACE standard doesn't directly address performance per se, and so that could be related to determinism. So certainly you need determinism for flight cert. I'd say the architecture lends itself to demonstrating determinism, but it doesn't explicitly address it.
Yeah,
So
I would follow on and say there's nothing within the FACE standard that's going to prevent determinism. And, you know, using the TSS and some of those interfaces, you should be able to go off and build yourself a deterministic system on top of your network or whatever IO you're utilizing.
Yeah. ARINC 653, which you require under all the profiles, does provide partitioning, which gives you a lot of your determinism kind of right out of the box. So provided that you're meeting ARINC 653, that gets you part of the way there. But certainly determinism is a broad question that flight cert is going to force you to answer and provide evidence for.
Yeah, and also don't forget the FACE standard has the general purpose profile, which is aimed at non-safety applications or not necessarily real-time applications. So there you could build applications using the, the general purpose profile, where you'd be using something like a Linux operating system that does not require determinism as such. So I think FACE is broader than that. I think the deterministic arguments come down within the safety and security profiles, where the standard that you would use to test them against, so DO178 or whatever you're using, would specify the deterministic requirement, especially at the higher levels, DAL-A and such like.
Excellent, very good. And I am looking at the clock. I can see it's 49 minutes past the hour, so we only have a few minutes left. I know we have a number of questions in the Q&A and in the chat. We're going to try to address those questions offline best that we can. But let me just kind of go around maybe one last time to each panelist. And I'll just ask something briefly, but by all means, feel free to add any other remarks that you like. Alex, earlier you brought up safety-based profile. And maybe just for the benefit of the audience that we have here on this panel with us today, could you maybe say a few words about the significance of the safety-based profile?
Yeah, so as I just mentioned in my last answer, the FACE standard addresses really 4 different types of application you might develop within an avionics environment: a general purpose application using the general purpose profile, a safety application. And in fact, there are 2 standards. Steve mentioned them both earlier, 2 profiles: the safety-based profile, which is more or less the ARINC 653 APIs with a few POSIX APIs thrown in, and the extended safety profile, which has some extra POSIX APIs for those kinds of applications, and then a security API aimed at secure systems. And really the idea is, and again, we've all worked in safety for a number of years, you really want to try and reduce the subset of different APIs that you're putting through the safety certification process, so you can concentrate and make sure that your safety arguments for those is very robust. And so to do that, this is where the ARINC 653 standard came in, with just a very small number of APIs that need to be tested. So we can prove to a very high degree of confidence that they're safe. So the safety-based profile is aimed exactly at that, the minimum set of APIs that you need to go through a safety certification process.
Thank you for that clarification. Steve, anything you'd like to share with the group that's here with us today as a final remark?
I'm going to just pitch one more time for participation. If you're a member of FACE, show up at the quarterly meetings. They've been virtual for the last couple are under COVID, but eventually we'll get back to in person. And let me know if you're interested in EA25. I'd love to have additional participation there. In fact, I'll put my email on the chat here for folks that want to get a hold of me about that.
Excellent. Thank you for doing that, Steve. And maybe, Levi, to kind of bring it again back up to sort of where we started. So how does someone who wants to get started with FACE, what should that individual do? What's the best way to get started, if you will?
Well, I really think probably the best way to get started with FACE is, attending the FACE Consortium is a really great way. There's a 101 session that's held. While virtual is not ideal right now in terms of being able to get into face-to-face meetings, it's really great that we can increase participation. I mean, in the last 2 meetings, we've seen a significant increase in the amount of folks that can participate, and we think we'd like to introduce a virtual element to it. So attending FACE, participating in FACE, but then also, going out to the FACE, going out to the website, downloading the standard and getting familiar with it. Read through it. I mean, it's not the greatest read on earth. I mean, it's a standard, but in the first, few pages, you can really get a feel for what it is and understand of the layers that we develop. So that's kind of how I'd recommend getting involved in FACE.
I think that's a great recommendation. And as all of you pointed out, we're seeing FACE conformance anyway becoming a more common set of requirement from program flow downs anyway. So I think it benefits all of us to become more familiar with the standard itself.